Hello dear students, good morning. Welcome back to the chemistry class. In the last class, we have discussed about the concept of a vapor pressure. One of the colligative property we have completed. In today's session, I will explain few problems on RLVP, that is relative lowering in vapor pressure. So let's start with the first problem. The question paper link is given in the description box. Please download the question paper and solve the numericals. First question is number 1. The first question: vapor pressure of ethanol, that is ethyl alcohol, is given. That is, vapor pressure of ethanol is 40 mmHg. Its mole fraction in a solution with the methanol is 0.80. Mole fraction is given. What will be its vapor pressure in the solution if it obey Raoult's law? Very simple question. The first question is, so I am writing the given data. The first question: the vapor pressure of ethyl alcohol is 40 mmHg. What is the question? The vapor pressure of, the question is, the vapor pressure of ethyl alcohol, ethanol, it is given 40 mmHg, and its mole fraction in a solution with methanol, its mole fraction is given, its mole fraction with methanol CH3OH is, its mole fraction with methanol is given, that is 0.80. Mole fraction is given, and the question is, what is its vapor pressure in the solution if it obeys Raoult's law? Vapor pressure of ethanol, ETOH, in solution is equals to question mark. What is its vapor pressure if it obeys Raoult's law? So here directly it is given. Raoult's law means what? Vapor pressure of ethanol, ETOH, vapor pressure of ethanol is equals to, so P is equals to P naught into X. So P naught of ETOH into its mole fraction of ethanol, So both the terms it is given. Vapor pressure of ethanol is given, that is in its pure form, its value is given, that is 40 mmHg, into its mole fraction, that is 0.80. So when it is multiplied, it becomes more than, that is 32 mmHg. So this is the first question. 32 mmHg, it is the answer. Next, second question. When 10 gram of glucose is dissolved in 90 gram of water, a solution is prepared by 10 gram of glucose dissolved in 90 gram of water. If the vapor pressure of pure water is 32.8 mmHg, then what would be its vapor pressure in solution? Vapor pressure of solutions is asking. So here the question, given data, 10 gram of glucose is dissolved in 90 gram. 10 gram of glucose is dissolved in 90 gram of water. 90 gram of water. This is the first point given. And if the vapor pressure of pure water, pure, that is P naught H2O, is 32.8 mmHg. Vapor pressure of pure water is given. Then what would be the vapor pressure of solutions? That is P is equals to question mark. So according to the Raoult's law, solution, according to the Raoult's law, vapor pressure of solution is equals to P naught into X. So here P naught into X. 10 gram of glucose is dissolved in 90 gram of water. I want mole fraction. So what is the formula for that? Mole fraction is equals to, we know that the mole fraction formula, mole fraction is equals to number of moles of that component divided by total number of moles. So here mole fraction of water, that is component A, is equals to number of moles of A plus number of moles of B, total Na plus Nb. Now number of moles, how to calculate? This is the solute. So given mass is 10 gram divided by molar mass of glucose is glucose, formula C6H12O6 and its mass is 180. So this is the number of moles of solute, Nb value. Whereas Na value, number of moles, given mass is 90, molar mass of water is 18. So these two are known. Indirectly it is given 10 gram of glucose solute and solvent. So here P naught, that is for water, and in this case glucose is non-volatile solute. So therefore vapor pressure is due to solvent only. So it is solvent into mole fraction. It's mole fraction. Total vapor pressure is equals to P naught into X. That is its mole fraction A. So X way. So Na, its value, Na, that is solvent, its value is 90 by 18, that is 5 divided by, here it is 19 by 18 plus Nb solute 10 divided by 180. So simplify this. So here it is 5 divided by 90 by 18, 5 plus, so 1000 by 18 is 55.5, 1 2 digit 0.55, 0.055 0.055. Once you verify the calculations, so the final answer is in this case. So upon simplifying this, verify this. So after simplifying this, the final answer in this case is, that is equals to XA is equals to, it is 0.989 mole fraction of solvent. P naught is known, that is 32.8 into 0.989. So the final answer in this case is, that is 32.44 mmHg. Is it clear? So vapor pressure of solution is equals to 32.44. This is the second problem. Is it clear? A very simple concept is there. So vapor pressure of solutions and vapor pressure of the solvent. Total vapor pressure of solutions we have calculated by the given data. Next problem. The vapor pressure of pure benzene is 0.256 bar and vapor pressure of toluene is given, that is 0.0925. If the mole fraction of benzene is 0.4, then calculate the total vapor pressure of the solution and the composition in vapor phase. Let's see. The vapor pressure of pure benzene, that is vapor pressure of benzene, and the vapor pressure of toluene C7H8, C6H5, that is benzene with CH3, toluene C7H8. Vapor pressure of benzene and toluene it is given. So in pure form, that is vapor pressure of benzene is, the vapor pressure of benzene is 0.256 bar, it is given, and the vapor pressure of toluene is 0.0925 bar. The vapor pressure of pure benzene and toluene are 0.526 bar and 0.0925 respectively. So these two data it is given. If the mole fraction of benzene is C6H6, the mole fraction of benzene is 0.40. if the mole fraction of benzene is 0.4, then what will be the total pressure of the solution? Total pressure of the solution is equals to question mark. This is the first one. And the second question is, what is the composition? What is the composition in vapor phase? Composition in vapor phase. Composition in vapor phase. That is mole fraction in vapor phase is equals to question mark. So now let us calculate the first one. So what is the total pressure of the solution? So here total pressure is equals to PT is equals to partial pressure of benzene plus partial pressure of toluene, partial pressure of benzene and toluene. Now partial pressure of benzene and toluenes, they are not given, but in pure form it is given. So according to the Raoult's law, P can be written as P naught into X. So here P naught of benzene into its mole fraction plus P naught of toluene into its mole fraction. So let us write for benzene. I am writing as, for benzene it is B, and for toluene let's write small t, toluene. So mole fraction of benzene, mole fraction of toluene. So here P naught of benzene and toluene are known, but mole fraction of benzene and toluene. Mole fraction of benzene is given 0.4. So what about the mole fraction of toluene? Mole fraction of toluene C7H8. Mole fraction of toluene is 0.6. So why it is 0.6? Sum of mole fraction of benzene and toluene is equals to 1. So sum of mole fraction of benzene and toluene is equals to 1. Therefore 1 minus benzene, that gives 0.6. Substitute and simplify. P naught B 0.256 into XB value 0.4. This is partial pressure of benzene plus mole fraction of toluene and its vapor pressure 0.0925 into 0.6. This is for toluene. So multiply and simplify. So here its value is 0.1024 plus next value 0.0555. 0.055. So the final answer 0.158 bar. 0.158 bar. This is total vapor pressure of the solution which is formed by the mixture of benzene and toluene. Now, what will be the mole fraction? The second one, composition of vapor phase. Composition in vapor phase. Please note this, it is an important formula. Mole fraction in vapor phase is given by, suppose for a binary solution, component A and B, mole fraction of any component in its vapor phase is equals to partial pressure of that component divided by total pressure. Total pressure, please note this formula. Mole fraction of the particular component in vapor phase is given by, it is the ratio of partial pressure of that component divided by total pressure. So here mole fraction of benzene in vapor phase is given by partial pressure of benzene is 0.1028, 0.1024 divided by total vapor pressure. Total vapor pressure is equals to 0.158. This is the answer. So whereas for toluene its value is 0.0555 divided by 0.158. So simplify and write the answer. So here verify this answer. 0 point is given 0.648. So in book this is the answer once you verify the calculations. And the second one is 0.351. So the sum of mole fraction of all the component is equals to 1. You can verify 0.648 plus 0.351 351 is approximately, it is nearly equals to 1. So this is the first question and this is the second question. The first question is the total vapor pressure of the solution, that is I have calculated according to Dalton's law of partial pressure. Total vapor pressure is equals to partial pressure of benzene and toluene. But according to the Raoult's law, partial pressure of benzene is given by P naught into X. So P naught into X. P naught values are given. XB is given. XA is calculated indirectly and then substitution, simplification. So this is the next problem. Okay, right. Please note this next problem. The vapor pressure of chloroform and dichloromethane. The vapor pressure of dichloromethane and chloroform are given. Calculate the total pressure if a solution is prepared by this. Okay. Note down the given data in this case. A solution is prepared by 25.5 gram of chloroform formula CHCl3 plus 40 gram of dichloromethane CH2Cl2. A solution is prepared by mixing of 25.5 gram of chloroform and 40 grams of dichloromethane. A solution is prepared. So, when the solution is prepared, what will be the total pressure of this solution is equals to question mark. Calculate the total pressure of the solution. So, what is the total pressure of the solution found by the mixing of these two components? And it is given the vapor pressure of dichloromethane and chloroform CHCl3 and P naught of CH2Cl2, that is in pure form, its value is given 200 and 415 mmHg respectively. mmHg respectively. Vapor pressure in pure form is given. So calculate the total pressure of the solution. Now, to calculate this total pressure, we have the formula. Total pressure is equals to partial pressure of chloroform CHCl3 plus partial pressure of dichloromethane. So dichloromethane. These two values we don't know. So let us calculate first these two values according to the Raoult's law. This can be written as P naught of CHCl3 and its mole fraction plus P naught of dichloromethane into its mole fraction CH2Cl2. So mole fraction is not given. First step, let us calculate the mole fraction, because these two terms are given. Mole fraction you need to calculate and substitute. So how to calculate the mole fraction? So before to calculate the mole fraction, we must and should know about the number of moles. So here given mass is known. Let us convert this given mass into number of mole. So number of moles of chloroform CHCl3, number of moles is equals to given mass divided by molar mass. What will be the molar mass? So here 35.5 into 3 plus 1 plus 12. So it is 35.5 into 3. 105, 106.5, 107.5 and 12, 109, 119.5. Number of moles of chloroform. Whereas number of moles of dichloromethane CH2Cl2 is equals to 40 divided by 35.5 into 2, 71, 72, 73, 75, 85. The molar mass of dichloromethane. So these two terms, calculate this. So here number of moles of chloroform and dichloromethane, it comes to 0.213 and for dichloromethane it is 0.470. So therefore, if number of moles is known, we can calculate mole fraction of CHCl3 chloroform is equals to number of moles 0.213 divided by 0.213 plus 0.470. So this comes out to mole fraction 0.312, 0.312. So this is mole fraction of chloroform. Then what about the mole fraction of dichloromethane? CH2Cl2. 1 minus this 1 minus 0.312, it comes to 0.688, okay, 0.688, the mole fraction of, because sum of mole fraction of these two components is equals to 1. So directly I have written, so 1 minus this value, so that comes to 0.688. Now mole fraction values are known. To a partial pressure of these components in pure form, it is given. So substitute and simplify. For chloroform, 200 into its mole fraction, that is 0.312, plus 415 into 0.688. So this gives rise to 62.4 plus 288.5. So therefore total vapor pressure is equals to 347.9. Once you verify the calculation, total vapor pressure is equals to 347.9. So here one small work, you can calculate the composition in vapor phase. Mole fraction of chloroform is equals to question mark, and mole fraction of dichloromethane is equals to question mark. Let us calculate these two. Mole fraction in vapor phase. Is it clear? Yes, it is very simple concept. Next one. The vapor pressure. Next question. The vapor pressure of a solution containing 3 moles of X and 1 mole of Y is 550, but when 4 moles of X and 1 moles of Y is mixed, the vapor pressure becomes 560. What will be the vapor pressure of pure component? So here the question, the given data, vapor pressure of a solution containing 3 moles of X plus 1 moles of Y, and its total vapor pressure is given, that is 550. But when 4 moles of X, the second condition, 4 moles of X when it combines with 1 mole of Y, then the total vapor pressure is 560. If so, then calculate what will be the value of P naught X and Y is equals to question mark. P naught X and Y is equal to question mark. So what is the formula? Total vapor pressure PT is equals to Px plus Py. So according to the formula, Px is equals to P naught X into mole fraction of X plus P naught Y into mole fraction of Y. So mole fraction we required. P naught is not known, but Pt is given. In the first case, it is 550. So in first case, let us consider the first case. So here mole fraction is equals to total moles. Mole fraction of X is equals to number of moles of X, that is 3, divided by total number of moles is 4, that is 3 by 4. Similarly, mole fraction of Y is equals to 1 by 4 in the first case. Substitute and simplify. P naught X into 3 by 4 plus P naught Y into 1 by 4, that is equals to 550. So 4 it is 2200 is equals to 3 into P naught X plus P naught Y. Equation number 1. Now in the second case, so Pt is equals to 560 in second case. P naught X into, what will be the mole fraction in second case? 4 by 5. 4 divided by 5 plus P naught Y into 1 by 5. So into 5 means 2800 divided is equals to 4 P naught x plus P naught y, equation number 2. Simplify these two equations and find out the value of P naught x and y. So in both the case P naught y, it is 4 and it is 3. Equation 2 minus 1 gives, equation 2 minus 1 implies, so 2 minus 1, 2. 2800 minus 2200, that is 600 is equals to P naught y get cancels, 4 minus 1, that is P naught x value is 600. Now substitute that P naught x value in any one of the expression and will use P naught y. So 3 or 1800, 2200 minus 1800 is, that is 400. Yes, P naught y is equals to 400. Is clear? Yes. So note the formula and answers once you verify the calculations and solve the remaining problem. Remaining 10 problems you need to solve today itself, and by evening you can send its answers, remaining 10 questions. And in the next class I will do a more DPP on this concept and will go for the second colligative property, that is elevation in boiling point. Okay, thank you.